Hey folks, my name is Addy. This is Eva. We work on Chrome, and today we're going to give you a whirlwind tour of tips and tricks for making your sites load fast. So let's get started.
The internet gets heavier and heavier every year. If we check in on the state of mobile web, we can see that a median page on mobile waits at about 1.5 megs, with majority of that being JavaScript and images. That's quite a lot. Apart from the sheer size, though, there are other reasons why a web page might feel sluggish and heavy. Third-party code, network latency, CPU limitations, parser blocking patterns, all of these contribute to the complicated performance puzzle. We've been pretty busy over past year trying to figure out how to fit this rich content of mobile web into the smallest package possible. In this talk, Addy and I are going to show you what you can do in this regard today, but also we'll take a peek into the future and give you a highlight of what might be possible really, really soon.
So I'm not the biggest fan of suitcases. The last time I was at the airport waiting at the baggage carousel for my bags, I looked around for my suitcase, and all I could find was this. I, too, laughed the first 4 times this went around. I was really happy to get this back. I just wanted more of it. Now, the experience that I had at a baggage carousel is a lot like the experience our users have when they're waiting for a page to load. In fact, most users rate speed as being at the very top of the UX hierarchy of their needs. And this isn't too surprising, because you can't really do a whole lot until a page has finished loading. You can't derive value from the page. You can't admire its aesthetics. Now, we know that performance matters, but it can also sometimes feel like a secret, discovering where to start optimizing. And so we've been working on trying to make this problem a little easier for a while. And today, we have an exciting announcement to share with you. We like to call it a Paul Irish in your pocket.
Well, we're happy to announce a newly expanded set of web performance audits in Lighthouse. Lighthouse, as you know, is part of developer tools that allow you to make an audit of your website and also gives you hints on how to make it better. It's been around for a while, right? But as some of you have heard today in the morning, it's been also actively worked on. And today, I'm happy to share with you some of the newest audits that landed in Lighthouse over past quarters. We'll try to show them to you in action during the rest of the talk.
Oh, next one's yours.
As the internet saying goes, fixing web performance is as easy as drawing a horse, right? You just need to follow some steps carefully. But even though, well, there is some truth in the picture above, the good news is you can get pretty far by following some simple steps. In order to show you these steps, Addy prepared something special for you.
So Eva and I are really big fans of Google Doodles. Google's been doing them since 1998, and we thought it'd be fun to create a nice little app where we can show you some of our favorite interactive doodles from over the years. We call it the Oodle Theater. Here it is in action. So we kick it off with a drive-thru, and as we can see, we can now start browsing through the application, looking at doodles over the years. We could click through to one and even start playing. We're not going to ruin the surprise. You can go and you can play some of these in your own time, just not during this talk, please. So let's begin our journey into the wild west of web performance, and it all begins with one tool.
Of course, Lighthouse. The initial performance of our app, as you can see on this Lighthouse report, was pretty terrible. On a 3G network, the user needed to wait for 15 seconds for the first meaningful paint or for the app to get interactive. Lighthouse highlighted a ton of issues with our site, and the overall performance score of 23 mirrored exactly that. The page waited at about 3.4 megs. We desperately needed to cut some fat. This started our first performance challenge. Find things that we can easily remove without affecting the overall performance experience. So what is the easiest thing to remove? Usually nothing. And by nothing, I mean things that do not really contribute to the code, like white space or comments. Lighthouse highlights this opportunity in the Minify CSS and Minify JavaScript audit. We were using Webpack for our build process, so in order to get minification, we simply used the Uglify.js plugin. Minification is a common task, so you should be able to find a ready-made solution for whichever build process you happen to use. Other useful audit in that space is enable text compression. There is no reason to send uncompressed files, and most of the CDNs support this out of the box these days. We were using Firebase hosting to host our code, and Firebase actually enables gzipping by default. So by the sheer virtue of hosting our code on a reasonable CDN, we got that for free. And while gzip is a very popular way of compressing, other mechanisms like Zopfli and Brotli are getting traction as well. Brotli enjoys support in most of the browsers these days, and you can use a binary to pre-compress your assets before sending them to the server. OK, in these two ways, we made sure that our code is nice and compact and ready to be sent to the user. Our next task was to not send it twice if not necessary. The inefficient cache policy audit in Lighthouse helped us notice that we could be optimizing our caching strategies in order to achieve exactly that. By setting a max stage expiration header in our server, we made sure that on a repeated visit, the user can reuse the resources they have downloaded before. Ideally, you should aim at caching as many resources as securely possible for the longest possible period of time and provide validation tokens for efficient revalidation. All the changes we made so far were very straightforward, right? They required no code whatsoever. It was a really low-hanging fruit with very little risk of breaking anything. So remember, always minimize the code, preferably automating it with build tools by using the right CDNs or by adding optimization modules to your own servers. Always compress your assets and use efficient cache policies to optimize repeated visits. OK, this way we removed the obvious parts of the unnecessary download. But what about the less obvious parts? For example, unused code. As it happens, unused code can really surprise us. It may linger in the dark corners of your code base, idle and long forgotten, and yet making it to the user's bandwidth each time the app is loaded. This happens especially if you work on your app for a longer period of time, your team or your dependencies change, and sometimes an orphan library gets left behind. That's exactly what happened to us. At the beginning, we were using Material Components library to quickly prototype our app. In time, we moved to a more custom look and feel, and of course, we forgot entirely about that library. Fortunately, the code coverage check helped us rediscover it in our bundle. You can check your code coverage stats in DevTools, both for the runtime as load time of your application. You can see the two big red stripes in the bottom screenshot. We had over 95% of our CSS unused, and a big bunch of JavaScript as well. Lighthouse also picked up this issue in the unused CSS rules audit. It showed a potential saving of over 400 kilobytes. So we got back to our code, and we kicked out both the JavaScript and CSS part of that library. This brought our CSS bundle down 20-fold, which is pretty good for a tiny 2-line long commit, right? Of course, it made our performance score go up, and also the time to interactive got much better. However, with changes like this, it's not enough to check your metrics and scores alone. Removing actual code is never risk-free, so you should always look out for potential regressions. Remember that our code was unused in 95%? Well, there's still this 5%, right? Apparently, one of our components was still using the styles from that library, the little arrows in the doodle slider. Because it was so small, though, we could just go and manually incorporate those styles back into the buttons. So if you remove code, just make sure you have a proper testing workflow in place to help you guard against potential visual regressions. So remember, code coverage both in DevTools and in Lighthouse is your friend when it comes to spotting and removing unused code. Do this check regularly throughout the development of your app to keep your code base clean and tidy and to test your changes thoroughly before deployment. Well, so far so good. All of those changes made our app a little bit lighter. It was still too slow to Addy, so he took it a bit farther. Addy, how did it go?
It went so good. Now, some web pages are like heavy suitcases. You have some stuff that's really important, and then you have crap and even more crap. We know that large resources can slow down web page loads. They can cost our users money, and they can have a big impact on their data plans. So it's really important to be mindful of this. Now, Lighthouse was able to detect that we had an issue with some of our network payloads using the enormous network payload audit. Here we saw that we had over 3 megs worth of code that was being shipped down, which is quite a lot, especially on mobile. At the very top of this list, Lighthouse highlighted that we had a JavaScript vendor bundle that was 2 megs of uncompressed code that we were trying to ship down. This is also a problem highlighted by Webpack. Now, what we say is that the fastest request is the one that's not made. Ideally, you should be measuring the value of every single asset you're serving down to your users, measuring the performance of those assets, and making a call on whether it's worth actually shipping down with the initial experience. Because sometimes these assets can be deferred or lazily loaded or processed during idle time. In our case, because we're dealing with a lot of JavaScript bundles, we were fortunate because the JavaScript community has a rich set of JavaScript bundle auditing tools. We started off with Webpack Bundle Analyzer, which informed us that we were including a dependency called Unicode, which was 1.6 megs of parsed JavaScript, so quite a lot. We then went over to our editor, and using the import cost plugin for visual code, we were able to visualize the cost of every module that we were importing. This allowed me to discover which component was including code that was referencing this module. We then switched over to another tool, Bundlephobia. This is a tool which allows you to enter in the name of any NPM package and actually see what its minified and gzip size is estimated to be. We found a nice alternative for the slug module we were using that only weighed 2.2 kilobytes, and so we switched that up. This had a big impact on our performance. Between this change and discovering other opportunities to trim down our JavaScript bundle size, we saved 2.1 megabytes of code. We saw 65% improvements overall once you factor in the gzipped and minified size of these bundles, and we just found that this was really worth doing as a process. So in general, try to eliminate unnecessary downloads in your sites and apps. In the case of the Oodle Theater, an app that already has games and a lot of interactive multimedia content, it's important for us to keep the application shell as lightweight as possible. We found that inventorying our assets and measuring their performance impact made a really big difference. So just make sure that you're auditing your assets fairly regularly. Now, although large network payloads can have a big impact over our app, there's another thing that can have a really big impact, and that is JavaScript. We all love JavaScript, but as we saw earlier, the median page includes a little bit too much of it. JavaScript is your most expensive asset. On mobile, if you're sending down large bundles of JavaScript, it can delay how soon your users are able to interact with your user interface components. That means they can be tapping on UI without anything meaningful actually happening. So it's important for us to understand why JavaScript costs so much. This is how a browser processes JavaScript. We first of all have to download that script. We have a JavaScript engine which then needs to parse that code, needs to compile it, and execute it. Now, these phases are something that don't take a whole lot of time on a high-end device like a desktop machine or a laptop, maybe even a high-end phone. But on a median mobile phone, this process can take anywhere between 5 and 10 times longer. This is what delays interactivity, so it's important for us to try trimming this down. Now, to help you discover these issues with your app, we introduced a new JavaScript Boot-up time audit to Lighthouse. And in the case of the Oodle app, it told us that we had 1.8 seconds of time which was being spent in JavaScript Boot-up. what was happening was that we were statically importing in all of our routes and components into one monolithic JavaScript bundle. One technique for working around this is using code splitting. So code splitting is this notion of instead of giving your users a whole pizza's worth of JavaScript, what if you only gave them one slice at a time as they needed it? Code splitting can be applied at a route level or a component level. It works great with React and React Loadable, Vue.js, Angular, Polymer, Preact, and multiple other libraries. So we incorporated code splitting into our application. We switched over from static imports to dynamic imports, allowing us to asynchronously lazy load code in as we needed it. And the impact this had was both shrinking down the size of our bundles, but also decreasing our JavaScript boot-up time. Took it down to 0.78 seconds, making the app 56% faster. So in general, if you're building a JavaScript-heavy experience, be sure to only send code to the user that they need. Take advantage of concepts like code splitting, explore ideas like tree shaking, and check out this repo we have with a few ideas around how you can trim down your library size if you happen to be using Webpack. Now, as much as JavaScript can be an issue, we know that unoptimized images can also be a problem too. So over to Ewa to talk about optimizing images.
Images. Internet loves images, and so do we. In Oodle we're using them in the background, in the foreground, and pretty much everywhere. Unfortunately, Lighthouse was much less enthusiastic about it than we were. As a matter of fact, we failed on all 3 images-related audits. We forgot to optimize our images, we were not sizing them correctly, and also we could get some gain from using other image formats as well. So we started optimizing our images. For one-off optimization rounds, you can use visual tools like Image Optim or XNConvert. A more automated approach is to add an image optimization step to your build process with libraries like, for example, ImageMin. This way, you make sure that also the images added in future get optimized automatically. Some CDNs, for example, Akamai, or third-party solutions like Cloudinary or Fastly, offer you a comprehensive image optimization solutions. So to save yourself some time and headache, you can simply host your images on those services. If you don't want to do that because of the cost or latency issues, projects like Thambor or ImageFlow offer self-hosted alternatives. Here you can see a single image optimization outcome. Our background PNG was flagged in Webpack as big, and rightly so. After sizing it correctly to the viewport and running it through Image Optim, we went down to 100 kilobytes, which is acceptable. Repeating this for multiple images on our site allowed us to bring down the overall page weight significantly. That was pretty easy for static images. But what about the animated content? As much as we all love GIFs, especially the ones with the cats in them, they can get really expensive. Surprisingly, the GIF format was never intended as an animation platform in the first place. Therefore, switching to more suitable video format offers you large savings in terms of the file size. In Oodle, we were using a GIF you saw earlier as an intro sequence on the homepage. According to Lighthouse, we could be saving over 7 megabytes by switching to a more efficient video format. Our clip weighted about 7.3 megs, way too much for any reasonable website. So instead, we turned it into a video element with 2 source files, an MP4 and WebM, for wider browser support. Here you can see how we used FFmpeg tool to convert our animation GIF into the MP4 file. The WebM format offers you even larger savings, and for example, Image Optim API can do such conversion for you. We managed to save over 80% of our overall weight thanks to this conversion. This brought us down to around 1 megabyte. Still, 1 megabyte is a large resource to push down the wire, especially for the user on a restricted bandwidth. Luckily, we could use Effective Type API to realize they're on a slow bandwidth and give them a much, much smaller JPEG instead. This interface uses the effective round-trip time and downlink values to estimate the network type the user is using. It simply returns a string, slow 2G, 2G, 3G, or 4G, So depending on this value, if the user is on below 4G, we could replace the video element with the image. It does remove a little bit from the experience, but at least the site is usable on a slow connection as well. Last but not least, there is a very common problem of off-screen images. Carousels, sliders, or really long pages often load images even though the user cannot see them on the page straight away. Lighthouse will flag this behavior in the off-screen images audit, and you can also see it for yourself in the network panel of DevTools. If you see a lot of images incoming while only few are visible on the page, it means that maybe you could consider lazy loading them instead. Lazy loading is not yet supported natively in the browser, so we have to use JavaScript to add this capability. Here you can see how we use lazy sizes to add lazy loading behavior to our UDL covers. Lazy sizes is smart because it does not only track the visibility changes of the element, but it also proactively prefetches elements that are near the view for the optimal user experience. It also offers an optional integration with the intersection observer, which gives you very efficient visibility lookups. As you can see, after this change, our images are being fetched on demand instead of straight away. OK, that's a lot of good stuff about images. So just remember, always optimize images before pushing them to the user. Use responsive images techniques to achieve the right size of the image. Use lighter formats wherever possible, especially for animated content. And finally, lazy load whatever is not immediately visible to the user. If you want to dig deeper into that topic, here's a present for you. A very handy and comprehensive guide written by Addy. So you can access it at images.guide URL.
Cool. So let's talk about resources that are discovered and delivered late by the browser. Now, not every byte that's shipped down the wire to the browser has the same degree of importance, and the browser knows this. A lot of browsers have heuristics to decide what they should be fetching first. So sometimes they'll fetch CSS before images or scripts. Now, something that could be useful is us as authors of the page informing the browser what's actually really important to us. Thankfully, over the last couple of years, browser vendors have been adding a number of features to help us with this. So things like link rel pre-connect or preload or prefetch. These capabilities that were brought to the web platform help the browser fetch the right thing at the right time. And they can be a little bit more efficient than some of the custom loading logic-based approaches that are done using script instead. So let's see how Lighthouse actually guides us towards using some of these features effectively. So the first thing Lighthouse tells us to do is avoid multiple costly round trips to any origin. Now, in the case of the UDL app, we're actually heavily using Google Fonts. Whenever you drop in a Google Font style sheet into your page, it's going to connect up to 2 subdomains. And what Lighthouse is telling us is that if we were able to warm up that connection, we could save anywhere up to 300 milliseconds in our initial connection time. Now, taking advantage of link rel pre-connect, we can effectively mask that connection latency. Now, especially with something like Google Fonts, where our font-face CSS is hosted on googleapis.com and our font resources are hosted on gstatic, this can have a really big impact. So we applied this optimization, and we shaved off a few hundred milliseconds. The next thing the Lighthouse suggests is that we preload key requests. Now, link rel preload is really powerful. It informs the browser that a resource is needed as part of the current navigation, and it tries to get the browser fetching it as soon as possible. Now, here Lighthouse is telling us that we should be going and preloading our key web font resources because we're loading into web fonts. Preloading in a web font looks like this. So specifying rel equals preload, you pass in as with a type of font, and then you specify the type of font you're trying to load in, such as WAF2. The impact this can have on your page is quite stark. So normally, without using link rel preload, if web fonts happen to be critical to your page, what the browser has to do is it first of all has to fetch your HTML, has to parse your CSS, and somewhere much later down the line, it'll finally go and fetch your web fonts. Using link rel preload, as soon as the browser has parsed your HTML, it can actually start fetching those web fonts much earlier on. In the case of our app, this was able to shave a second off the time it took for us to render text using our web fonts. Now, it's not quite that straightforward if you're going to try preloading fonts using Google Fonts. There is one gotcha. You see, the Google font URLs that we specify in our font faces in our style sheets happen to be something that the fonts team update fairly regularly. These URLs can expire or get updated on a regular frequency. And so what we suggest to do if you want complete control of your font loading experience is to self-host your web fonts. This can be great because it gives you access to things like link rel preload. In our case, we found the tool Google Web Fonts Helper really useful in just helping us offline some of those web fonts and set them up locally. So check that tool out. Now, whether you're using web fonts as part of your critical resources or it happens to be JavaScript, try to help the browser deliver your critical resources as soon as possible. If you're connecting up to multiple origins that are critical, consider using link rel preconnect. If you have an asset for the current page that's really important, use link rel preload. We happen to have a good preload plugin available for Webpack. And if you have an asset for future navigation, consider using prefetch. This is something that has good support now in the latest version of Webpack, as well as preload. Now, we've got something special to share with you today. In addition to features like resource hints, as well as preload, we've been working on a brand new experimental browser feature we're calling priority hints. This is a new feature that allows you to hint to the browser how important a resource is. It exposes a new attribute, importance, with the values low, high, or auto. This allows us to convey lowering the priority of less important resources, such as non-critical styles, images, or fetch API calls to reduce contention. We can also boost the priority of more important things like our hero images. In the case of our Oodle app, this actually led to one practical place where we could optimize. So before we added lazy loading to our images, what the browser was doing is we had this image carousel with all of our doodles. And the browser was fetching all of the images at the very start of the carousel with a high priority early on. Unfortunately, it was the images in the middle of the carousel that were most important to the user. So what we did was we set the importance of those background images to very low, the foreground ones to very high, and what this had was a 2-second impact over slow 3G and how quickly we were able to fetch and render those images. So nice positive experience. We're hoping to bring this feature to Canary in a few weeks, so keep an eye out for that. The next thing I want to talk about is typography. So typography is fundamental to good design. And if you're using web fonts, you ideally don't want to block rendering of your text, and you definitely don't want to show invisible text. We highlight this in Lighthouse now with the Avoid Invisible Text While Web Fonts Are Loading audit. If you load your web fonts using a font face block, you're letting the browser decide what to do if it takes a long time for that web font to fetch. Some browsers will wait anywhere up to 3 seconds for this before falling back to a system font, and they'll eventually swap it out to the font once it's downloaded. We're trying to avoid this invisible text, so in this case, we wouldn't have been able to see this week's classic doodles if the web font had taken too long. Thankfully, with a new feature called Font Display, you actually get a lot more control over this process. Font Display helps you decide how web fonts will render or fall back based on how long it takes for them to swap. Now, in this case, we're using Font Display Swap. Swap gives the font face a 0-second block period and an infinite swap period. This means the browser is going to draw your text pretty immediately with a fallback font if the font takes a while to load. And it's going to swap it once the font face is available. In the case of our app, why this was great is that it allowed us to display some meaningful text very early on and transition over to the web font once it was ready. So in general, if you happen to be using web fonts, as a large percentage of the web does, have a good web font loading strategy in place. There are a lot of web platform features you can use to optimize your loading experience for fonts. And also check out Zach Leatherman's web font recipes repo, because it's really great. Next up is Eva to talk about render blocking scripts.
So displaying visible text as early as possible is really important. But we can go further than that. There are other parts of our application that we could push earlier in the download chain to provide at least some basic user experience a little bit earlier. Here on the Lighthouse timeline strip, you can see that during this first few seconds when all the resources are loading, the user cannot really see any content. Downloading and processing external style sheets is blocking our rendering process from making any progress. So what can we do about it? Well, we can try to optimize our critical rendering path by delivering some of the styles a bit earlier. If we extract the styles that are responsible for this initial render and inline them in our HTML, the browser is able to render them straight away without waiting for the external style sheets to arrive. In our case, we used an NPM module called critical to inline our critical content in index.html during a build step. While this module did most of the heavy lifting for us, it was still a little bit tricky to get this working smoothly across different routes. The truth is, if you're not really careful or your site structure is really complex, it might be really difficult to introduce this type of pattern if you did not plan for app shell architecture from the beginning. This is why it's so important to take performance considerations early on. If you don't design for performance from the start, there is high chance you run into issues doing it later. In the end, our risk paid off. We managed to make it working, and the app started delivering content much earlier, improving our first meaningful paint time significantly. So to sum up, to unblock the rendering process, consider inlining critical styles in the head of your document and preloading or loading asynchronously the rest later on. For non-critical script, consider marking them with a defer attribute or lazy load them later during the app lifecycle. Okay, so that's the whole story of how we drew the horse and tried to put it in a suitcase. So let's take a look at the outcome. This is how our app loaded on a median mobile device on a 3G network, before and after the optimization. That's a pretty nice progress. All of this progress was fueled by us continuously checking and following the Lighthouse report. All of the hints you've seen today are linked in the Lighthouse tool so that you can check them in the context of your own application. If you'd like to check out how we technically implemented all of the changes, feel free to take a look at our repo, especially at the PRs that landed there. The performance score went up from 23 to 91. That's pretty nice, right? However, our goal was never to make Lighthouse happy. We wanted to make the user happy. And high-level metrics included in the report, like time to interactive or perceptual speed index, are a good proxy for improved user experience. Also, the snapshots timeline gives you a nice visual feedback about how much shorter the waiting time for our app became. This is the full story of Little Oodle app. Now, let's take a look at some much bigger businesses.
So Eva and I had the benefit of being able to think about performance very early on. But how does this apply at scale to much larger businesses? Well, let's take a look at Nikkei. Nikkei are Japan's largest media company. They have a site that's got 450 million users that are accessing it, and they spent a lot of time optimizing their old mobile site, turning it into a new PWA. The impact of performance optimizations was huge. They were able to get 14 seconds faster on interactivity. They saw a 230% increase in their organic traffic, 58% increase in conversion rates, and their daily active users and page views also went up. But what did they actually do to optimize their performance? Well, if we take a look at the full list of things that Nikkei did, they'll look a little bit familiar. That's because many of these are things that we covered today. Nikkei did things like optimize their JavaScript bundles. They were able to shrink them down by 43%. One big change they made was they actually used Webpack to optimize the performance of their third-party scripts in addition to their first-party ones. They were able to use link rel prefetch on their daily edition pages, improving next page performance loading by 75%. In addition to this, they also took advantage of the tip that Ewa was just walking through, critical path CSS optimizations. This is that optimization where you're sending down 14 kilobytes worth of content in your first round trip, and if you're able to squeeze in enough of your critical styles in there, you can actually improve first meaningful paint by quite a lot. So here, they were able to shave off a second of their first meaningful paint by taking advantage of this optimization. And finally, on Nikkei, they took advantage of the purple pattern. Now, purple is a pattern that was first discovered by the Polymer team a few years ago, and it stands for push, render, precache, and lazy load. So what Nikkei are doing is that they're pushing their critical resources using link rel preload and server push. They're rendering their main article content quite quickly. They're pre-caching their top stories using Service Worker, so this gives them offline access to read articles as well. And they're lazy loading code. So they're lazy loading code, and they're also using skeleton screens to improve the perceived performance of these pages. So we talked about how performance can help businesses to give users a better experience. But on users, we have one more thing that we think could help with the future.
Well, as you've heard during the keynote, we believe that machine learning represents an exciting opportunity for future in many areas. So what if we could take these two worlds of machine learning and web performance and blend them together? Maybe it could lead us to some really, really interesting solutions. Today, we want to tell you about our experience with machine learning and explain why we think it has a large potential. Here's an idea that we hope will spark more experimentation in the future, that real data can really guide the user experiences we're creating. Today, we make a lot of arbitrary decisions about what the user might want or need, and therefore what is being worth being prefetched or preloaded or precached. If we guess right, we are able to prioritize a small amount of resources, but it's really hard to scale it to the whole website. At the same time, we have a wealth of data about typical user behavior readily available. So Addy, how can we use that data?
So we actually have data available to better inform our optimizations today. Using the Google Analytics reporting API, we can take a look at the next top page and exit percentages for any URL on our site. In fact, we have a little tool for this that anybody can check out. Here it is for developers.google.com/web. And as we can see here, a lot of the users that land on the Chrome DevTools documentation actually end up going over to Lighthouse. So we could potentially prefetch that page. Folks that land up on the PWA docs will usually check out the PWA checklist. And we could use this data to improve our page load performance. This gives us the notion of data-driven loading for improving the performance of websites. But there is one piece missing here. Having a good probability model is important because we don't want to waste our users' data by aggressively over-prefetching content. We can take advantage of that Google Analytics data and use machine learning and models like Markov chains or neural networks in order to implement such probability models. This is a lot less subjective and error-prone than manually deciding what we should be prefetching or preloading for our sites. We can then wire this all up using link rel prefetch inside of our sites so that as the user browses through the site, we're able to actually fetch and cache things that they need ahead of time, improving our page load performance. Now, we can actually go further than this. Earlier, we talked about code splitting and lazy loading, but in a single-page app, we're often dealing with routes, chunks, and a bundler. So instead of just prefetching pages, we could actually go more granular. What if we could prefetch individual resources for a page or a number of pages? Well, across all of these ideas, we've been focused on trying to make some of these a little bit more low friction for web developers to adopt. And so today, we're happy to announce a new initiative we're calling Guess.js. Guess.js is a project focused on data-driven user experiences for the web. We hope that it's going to inspire exploration of using data to improve web performance and go beyond that. It's all open source and available on GitHub today. This was built in collaboration with the open source community by Minko Geshev, Kyle Matthews from Gatsby, Katie Hampenius, and a number of others. So let's take a look at what Guess.js provides us out of the box. The first thing it provides us is a Google Analytics module for analyzing our user navigations. It has a parser for popular frameworks, allowing us to map those URLs back to your framework's router. We then have a comprehensive Webpack plugin that's able to do machine learning training on some of that data to determine all of our probabilities. We're able to bundle the JavaScript for your routes and chunks with the potential for future clustering of those chunks. And we then are able to wire it all together for you so that we can prefetch those chunks of JavaScript as the user navigates through the site. We've also got experimental support for applying these concepts to static sites. Now, that's enough talk. What about showing you how this works in practice? So here we have a demo of Guess.js in action. What we're first going to do is we're going to load up our app. We're in the DevTools. We're in low-end mobile emulation over slow 3G. This app's rendered very quickly. And what we can see in the network panel is a number of routes that have already started to be prefetched because we have high confidence they're going to be used. We can toggle on a visualization of this. So in pink, we have pages we have high confidence the user's going to want. In green, we have low confidence, and in yellow, we have mild confidence. We can actually start to navigate through this application. So let's say we go to cheese. We can visualize this again. We can see that cheesecake is a page that users will often navigate to. As you can see, it loaded instantly because it's already in the user's cache by the time that they go to it. Contextually, we're able to display to you in this demo all the visualizations of confidence levels we have for different pages as we navigate through the site. Even this last page, the custard, loaded really, really quickly using these techniques. Now, prefetching is a great idea in practice, but we want it to be mindful of users' data plans. And this is where we use navigator.connection.effective type to make sure that we're only prefetching things when we think that your connection can handle it. So this is our demo of Guess.js using Gatsby. By the way, this also happens to be a PWA with a great performance score, so thank you to both Minko and Kyle for helping with this. Check out Guess.js, let us know what you think. So today we talked about quite a few things, but at the end of the day, performance is about inclusivity. It's about people. It's about all of us. We've all experienced slow page loads on the go, but we've gotten an opportunity today to consider trying to give our users more delightful experiences that load really, really quickly. So we hope that you took something away from this talk. Remember that improving performance is a journey. Lots of small changes can lead to really big gains. So check out some of the things we talked about today. Talk to us in the web sandbox if you've got any questions. That's it from us. Thank you.